Hello everyone. How do you prepare a topic for competitive exam like GATE? Do you simply understand the concept or do you also try to solve questions based on that? Sometimes even after studying a topic, we may not be able to solve all questions based on that. Why? Do you ever think about the reason? In fact, whenever we prepare a topic for any competitive exam, it is better to practice maximum possible previous year questions based on that topic. It will give an idea of the pattern of that exam, how the questions are being asked from each topic, and also helps to improve your time management. Today, I'm here with a video where we are going to solve K 2003 and 2004 questions on set transform. So, without further wasting time, let's get started. The first question I have for you is from K 2003. A sequence x of n with the set transform x of z is equal to z raised to 4 plus z raised to 2 minus 2z plus 2 minus 3z raised to minus 4 is applied as an input to a linear time invariant system with the impulse response h of n is equal to 2 into del of n minus 3, where del of n is equal to 1 for n equal to 0 and 0 otherwise. The output at n equal to 4 is dash. Four options are given: option A minus 6, option B 0, option C 2, and option D minus 4. Let us first analyze this question. Here we have a linear time invariant system. X of n is given as its input signal, and let us denote its output as y of n. The impulse response h of n of this system is given as 2 into del of n minus 3, and the set transform of the input sequence x of n is also given. We are asked to find out the output of the system at n equal to 4. So let us do that. You can see the block diagram of an LTI system here. X of n represents its input sequence and y of n its output. In fact, the output y of n of an LTI system can be mathematically expressed as y of n is equal to x of n convolution h of n, where x of n is the input sequence and h of n impulse response of the system. Now what we are going to do is we are going to take set transform on both sides of this equation. Y of set represents set transform of y of n. Now let me ask you a question. How can we find z transform of x of n convolution h of n? Any idea? In fact, convolution in time domain is equivalent to multiplication in frequency domain. So we can write y of z is equal to x of z into h of z. Let us denote this as equation number 1. X of z, the transform of input sequence x of n, is already given in question as z raised to 4 plus z raised to 2 minus 2z plus 2 minus 3z raised to minus 4. So what about h of z? How can we find its value? In fact, the impulse response h of n is given in question as del of n minus 3. So now we are going to find set transform of h of n. As you know, set transform of unit impulse del of n is equal to 1. From this, how can we find set transform of del of n minus 3? Any guess? Alright. In fact, we are going to use time shifting property of set transform to find h of z. According to time shifting property, if z transform of x of n is x of z, then that of x minus n0 is z minus n0 into x of z. Got it? Using this, we can write h of z as 2 into z raised to minus 2. Next, we are going to substitute the values of x of z and h of z in equation 1 and get y of z is equal to z raised to 4 plus z raised to 2 minus 2z plus 2 minus 3 z raised to minus 4 into 2 into z raised to minus 3. By rearranging it, we get 2z plus 2z raised to minus 1 minus 4z raised to minus 2 plus 4z raised to minus 3 minus 6z raised to minus 7. Thus, we obtained the value of y of z. What is our next task? Hope you remember, in the question we are asked to find out output y of n at n equal to 4. Which means first we have to find inverse Z transform of y of z to obtain y of n and find its value at n equal to 4. Let's do that. We know Z transform of unit impulse del of n is 1. Then by using time shifting property, we can write Z transform of del of n minus 1 as z raised to minus 1 and that of del of n plus 1 as z raised to 1. Or in other words, we can say that inverse Z transform of 1 is del of n, that of z raised to minus 1 is del of n minus 1 and that of z raised to 1 is del of n plus 1. Based on this, we are going to find inverse Z transform y of n from this y of z. Now you look at first term. It is 2z. What will be the corresponding inverse Z transform? Will be 2 into del of n plus 1. What about this term? 2z raised to minus 1. Correspondingly, we add 2 into del of n minus 1 in y of n. If we continue this process, we get y of n as 2 del of n plus 1 plus 2 into del of n minus 1 minus 4 del of n minus 2 plus 4 del of n minus 3 minus 6 del of n minus 7. In fact, we are asked to find out value of y of n at n equal to 4. I think we can plot y of n, then it will be easy for you to identify its value at n equal to 4. I hope you all know that this is the waveform of unit impulse function del of n, which is having a non-zero value 1 only at n equal to 0. Now we are going to perform time shifting operation on this signal. If we shift this del of n to left by 1 units, we get del of n plus 1 like this. And if we shift del of n to right by 1 unit, we get del of n minus 1 like this. And this is our del of n minus 3, which is obtained by shifting del of n to right by 3 units. And this is our del of n minus 2, which is obtained by shifting del of n to right by 2 units. And finally del of n minus 1, which can be obtained by shifting del of n to right by 7 units. Using this, we get the waveform of y of n like this, which is having non-zero value only at 5 time instance. At n equal to minus 1 it is 2, at n equal to 1 it is 2, at n equal to 2 it is minus 4, at n equal to 3 it has got an amplitude 3, and at n equal to 7 it is minus 6. Now tell me what is the value of y of n at n equal to 4. It is nothing but 0. Thus our answer is y of n is equal to 0 at n equal to 4. That is option B. Hope you all understood this problem perfectly. Moving on to next question. It's from K 2004. The Z transform of a system is h of z is equal to z by z minus 0.2. If ROZ is mod z less than 0.2, then the impulse response of the system is. 4 options are given. So here we have a system. H of n represents its impulse response and h of z represents Z transform of h of n. H of z is already given in question. We are asked to find out h of n. Let's do that. As you know, Z transform of minus a raised to n u of minus n minus 1 is z by z minus a with ROZ mod z less than mod a, where a is a constant. In our question, h of z is given as z by z minus 0.2 with ROZ mod z less than 0.2. By comparing these two, we get value of a as 0.2 and hence we can write the inverse z transform h of n as minus 0.2 whole raised to n u of minus n minus 1. Thus, our answer is option D. Got it? So, we are at the end of this session. Hope you all enjoyed it. If you have any doubts, please do let me know in the comment section. I'll definitely clear your doubts. Thanks for watching. Thank you.